Hey everybody, welcome back to IB Math. This is section 9C3, finishing up section C, which is our trigonometric identities section, and we're going to look at factorizing trigonometric expressions, and you'll notice we got the European spelling of factorizing there with our S. So what we're going to start with is kind of going maybe backwards a little bit and using some of our factoring rules. Before we were trying to simplify, we were multiplying things out, combining like terms and using our identities. We're going to use our identities again, but this time we're going to do some factoring and then see how we can simplify possibly based on factoring and maybe and canceling out factors when we get to some fractions. So let's dive into some examples and I'll show you what we mean here. So these are just asking us to factor, right? So what does factor mean? To unfoil or maybe to pull out common terms, right? So our first one, we have cosine squared alpha minus sine squared alpha. So I've got cosine squared alpha minus sine squared alpha. Now, what this really means is, just to recap, doesn't this really mean cosine alpha quantity squared minus sine of alpha quantity squared, right? Because we just write it as sine squared and cosine squared, but that's really what it means. So this is really, first of all, there's nothing I can pull out that's common, right? There's nothing common between cosine squared and sine squared. But this is really the difference of squares, right? Do you remember how difference of squares works? It's 1 plus the other times 1 minus the other. So if I were to factor this, just like it would any other normal difference of squares, I would say this is going to be cosine of alpha minus sine of alpha times cosine of alpha, alpha plus sine of alpha. And that's it. I factored out because it's difference of squares. Let's look at part B. That was A. Let's look at part B. I'll write it down here. Part B is tangent squared theta minus 3 tangent of theta plus 2. So this is a trinomial, right? This is something I want to unfoil. I have a squared term, I have a term that's not squared, and then I have a constant. So I'm going to try to unfoil this, and I know my first terms are going to be tangent theta and tangent theta because that's what gives me my tangent squared. And then I know I'm going to have a 2 and a 1 because 2 times 1 equals 2. And are they both going to be positive or both going to be negative? Well, in my middle term here, I've got a negative 3. So I know that negative 2 tangent theta and negative 1 tangent theta is going to give me my negative 3 tangent theta. So this is my factorization for part B. And again, if you look at the answers, I have them down here. You can see what we just did. And there's a good example right here. They kind of took each one and wrote them in terms of just variables instead of cosine and sine, which you might be a little bit more familiar with, and difference of squares and how to factor that as a trinomial. Great, let's try another one. So now we've got two fractions, and we want to simplify these. And the way we're going to simplify fractions, right, is you cancel out common factors between the numerator and the denominator. So that's what we're going to do here. So let's factor the numerator and the denominator and see if there's any factors that cancel. So the first one is I have 2 minus cosine squared theta over 1 plus cosine squared. So let's write this, 2 minus 2 cosine squared theta over 1 plus cosine theta. So let's see if we can factor the top. Well, the top I can pull out a 2, right? I'm going to be left with 1 minus cosine squared theta, right? And I'm down at the bottom, I have 1 plus cosine theta, okay? Now, the next thing you might look at and say, oh, well, 1 minus cosine theta, squared theta, that's kind of, is that equal to sine theta? Or, well, it's kind of, but if I change that to sine squared theta, I'm not going to be able to cancel anything. But look what I have on the bottom. I have 1 plus cosine theta. Isn't 1 minus cosine squared theta the top? Isn't this right here? Isn't that a difference of squares? Aren't 1 and cosine squared both squares? They are. So looking ahead to see, well, if I made this a difference of squares up top, couldn't this be 2 times 1 plus cosine theta times 1 minus cosine theta, right? Difference of squares, that's where I get 1 minus cosine squared. So instead of changing it to sine, I did that. And why would I do that? Because at the bottom, I've got 1 plus cosine theta, and now what can I do? These factors both cancel. And because they both cancel, then what am I going to be left with at the end? 2 times 1 minus cosine theta. And that's it. So by factoring the top in a way that by looking at the bottom, I knew that, could I get a common factor? And I did. I got 1 plus cosine theta on the bottom as well. Let's try another one. Let's try this one over here. I've got cosine theta minus sine theta over cosine squared theta minus sine squared theta. So the top really can't factor. I can't factor anything in the numerator, but the bottom, that's one we just looked at. That's a difference of squares, right? So let's rewrite this. So cosine theta minus sine theta, that can't simplify, but on the bottom, I'm going to have difference of squares. Cosine theta minus sine theta and cosine theta plus sine theta. And what happens here? Well, now I've got some factors that'll cancel, right? That factor and that factor cancels. Be careful. Before I did that, could I have just done this and canceled those out? Can't, because of that minus in between. So remember, you can only cancel entire factors that are multiplied by other factors. So this entire cosine theta minus sine theta, that's a whole factor multiplied by another factor. Now they can cancel. And then what does that leave me with? What's left up top in the numerator? Not 0, it's 1. And it's going to be 1 over, and on the bottom I've got cosine theta plus sine theta. And that's it for part B. Good? Great. Let's move on. I got one more example. There's the answer. You can see how they canceled as well. I've got one more example I want to solve for. Now, this is a little bit different. This isn't simplified. This is actually an equation. And you remember we did equations back in sections 9A and B. And I want to now look at solving, but using some of my skills of trig identities to be able to solve an equation. So I've got this, and I've got cosine squared, I got sine x. Doesn't look like I can do much with these, but it helps when I'm solving an equation if I only have one trig term, right? If I only have sine or cosine. So can I change that cosine squared into a sine squared? Well, I can, because I know that cosine squared is equal to 1 minus sine squared x, right? And then that stays the same on the other side here. Well, now if I multiply that out, what I'm going to get, 2 minus 2 sine squared x equals sine x plus 1. So now I've got everything in terms of sine. In this particular problem, I've got a sine squared and a sine, so it's like a trinomial, right? Oops, I didn't distribute that 2. Hold on. Let me erase that. I didn't distribute that 2, right? 2 minus 2. Why didn't somebody catch that and say something while I'm making the video? Anyway, I distributed the 2. I've got a sine squared and I've got a sine. This is like a trinomial, right? So I want to set everything equal to 0 and factor. I'm going to bring everything over to the right because I got that negative 2 up front. I want to make that positive. So I'm going to bring 0 here, and I'm going to bring everything to the right, and that's going to give me 2 sine squared x plus sine x. And then I bring the 2 over negative, it's going to be minus 1, right? So now I want to factor this. So I'm going to unfoil, and this is going to be 2 sine x and sine x. And then to equal negative 1, I'm going to have a 1 here and a 1 here. And I got to think which one. Now it's going to be one's negative, one's positive, right? Because I'm going to have a negative 1. Which one's negative, which one's positive? Well, I'm going to end up with a positive sine x in the middle. So that means this is going to be negative to give me negative 1 sine x. And that's going to be positive to give me 2 sine x. And negative 1 sine x and positive 2 sine x equals sine x. And if you're not quite sure, go ahead and FOIL it and make sure you can verify that we get that. Equals 0. How do we do this? This is what we did when we solved our equations before. I'm going to set each factor equal to 0 and solve for x. So 2 sine x minus 1 is equal to 0. And I've got sine x plus 1 equals 0. Let's do the left one first. 2 sine x equals 1 when I bring it over. Divide by 2. Right, sine x equals 1/2. Where does sine x equal 1/2? Well, that's going to be when x is 7, no, not 7 pi. Let's try that again. When x is equal to, whoops, where's it equal 1/2? When x is pi over 6, and when x is 5 pi over 6. And that's where my x is equal to, where the sine of those values are equal to 1/2. And now, what about this side? Sine of x equals -1. Oh, where does sine x equal -1? That's when x is equal to 3 pi over 2. So my answers are pi over 6, 5 pi over 6, and 3 pi over 2. And those are the radians, as it says up here, in this range, or in the domain of 0 to 2 pi. Make sense? Great. Those are the examples for today. So here's the assignment, just for 9 problems from section 9.C.3. One thing about section 4 is, if you look at the directions for number 4, it says show that, and they give you an equation, and they have a left-hand side and a right-hand side. This is what they do on the IB exam a lot, where they're basically giving you the answer. These are actually easier than numbers like, say, 1 and 3, where you're just simplifying and hope you get it right. They're actually saying, well, when you simplify it, you're going to get something on the right-hand side. So that means manipulate the left-hand side to get what you have on the right-hand side. And can you get there? So show the steps to get from the left to the right. Not subtracting things over, but taking that left-hand side expression and simplifying it like we did with some of the other problems earlier on, and then having it eventually equal what you have on the right-hand side. So they're giving you the answer. You just show the work on the left-hand side to end up getting the answer that's on the right-hand side. So check those out. If you have any questions, as always, please post in the discussion boards. Make sure you turn the assignment into eCampus on the assignment for section 9C3. And again, if you have any questions, don't hesitate to ask. Hope you all are doing well, and we'll talk to you next time. Take care.